Maybe some things will be like skeptical for you, but really we are the people who work with robots every day and who program them. And I have worked with many robotic platforms. At present we have 17 now robots in our lab, and they're really breaking down. But I also work with Asimo, and now we got these hands-on robots who have facial expressions, so they are opening the doors into new applications. And I think that social robots are coming, and maybe now is the time, like in 1977, when people used to think that there is no reason why people should have personal computers at home. So I think now the time of social robots is coming. And usually we talked about that people usually imagine robots as humanoid types and like social companions. But you know that the field of robotics is mainly in industry. There are many robotic arms, etc. And we still don't see these types of robots at homes. They're appearing, some of them, but at present we have really important application fields, like these robots are helping kids with autism, and the new field supported especially by European Union is ambient assisted living, where they can help with active aging at homes and special care centers. So I'm also involved in one Italian project where they are helping humans with many tasks, you know. And in the field of education, we do experiments like the robot is like a tutor, and he's showing exercises to children, and they have to exercise according to his motion. We also placed robots in schools, and they were teaching young kids, for example, some English words or colors or kinds of animals. And what's so special, because there are many research like this one. This is the difference. In social human interaction, social human-robot interaction, we use the technique of Wizard of Oz. It means that the robots are not autonomous. There's a human who is operating the robot, like using some joystick control or some other program, and he's observing the experiment and just pressing the button, like the robot knows how to respond because he's teleoperated. Yes, of course, we have also autonomous robots, like we had these iBodogs from Sony. The project was cancelled, but also in Denmark they have many Paro-Japanese robots. And I used to say that they're autonomous, but you have a limited behaviors that they can express. So usually in long-term interaction they are boring, because you know what they will do. And we want to bring some intelligence into these machines. We want to have them autonomous, but not only pre-programmed set of behaviors. So today I just want to tell you 2 steps how to bring intelligence into this system. So the very simple scenario is this one. The system, it can be a robot, it can be a mobile phone, perceive some human things like language, like command recognition, and it knows how to respond according to this stimuli. And that's okay. This stimuli can also be, like, this is from our emotion recognition software. These are our students during a class, and we are making experiments, and we are trying to recognize their emotions during the class, whether they are engaged in the lecture or not. And we are also using this type of software for robots, that the robot recognizes their emotional expressions from faces and from body language and from voice. So we are now able to do like not only one-to-one interaction, but also to recognize up to 70 people in one moment, and we obtain a graph. But this is the movie we are always talking about, her. And maybe you know the movie from Charlie Chaplin. So we can say that the eating machine is also a robot, and it responds somehow to the human. And we don't have a physical robot here, but we can imagine its actual system, etc. And the main difference, what I see from my point of view, is that her robot is learning from its experience. And this is the point. So, artificial intelligence is not only about robotics, but our goal is to make an intelligent robot. And the robot for us, it's a kind of image, sound, and data processing. I see it like this. And when I say intelligent, for me, it must be that it should be learning from its experience, from the environment, and also from the human partner. So, and we used to say that artificial intelligence is a new approach to programming, because we don't program scripts or some rules, like if you recognize hello, wave your hand. But I will show you some examples now. In advanced human-robot interaction, the robot can learn from demonstration, because imagine that not everybody is a programmer, but people want the robot to behave like they want, and if they can't write a program, there must be a way how to achieve it, and also learning from experience. So this is the video where, using Kinect, the human was teaching, only showing some emotional expressions that the Neu robot can copy and use them in the future. So it was one very simple example. And then I'm famous in Slovakia because I was the first one who programmed Neu robots to dance, and it appeared in every news. But I didn't program it manually. All dance, like these kinds of motions, angle interpolation, imagine, it would be very difficult. But the robot was learning how to dance, because it was done in human-robot interaction, and the human was evaluating its dances, and according to this evaluation, the system was able to generate new kinds of patterns. And now we want to bring this approach also into the wild, into some educational practices, where also the robot is interacting with children, and it is learning how to behave, how to motivate children into some funny and engaging educational process. So first of all, we come to the class, we explain kids like this is Neu robots. He will teach you some English words and nothing else. And then we leave the robot alone with children. There is no collaboration, and we are observing what's happening. Now we are coming to the field of artificial intelligence. We are using so-called reinforcement learning. It's an approach like from behavioral sciences. It's the same process like how do you educate your children. If the robot does something good, we give him like reward. It's only a kind of software function, and his goal is to maximize some notion of this reward. And you can start from some random behavior, and we are always observing whether the child is happy and if he is engaged in the educational process. And when he is, it means that the robot gets his reward. So he knows that this behavior was good, and he will be learning how to have the ideal way. And these behaviors, it can be anything. It can be motion, something that he says, like okay, something funny, some joke, anything. The other approaches of computational intelligence that we use are evolutionary computation, fuzzy systems, and neural networks. I will not go much in deep into this, just to give you a brief overview. Many of these approaches are bio-inspired, but we don't like if someone says that we are making a human brain. It's inspired, but they're only mathematical functions or coming from statistics, nothing else. For example, in evolutionary computation, you have some initial populations. It can be a behavior of the robot, and you start with the random generation of this behavior, and every time you evaluate and repeat this process. And the behaviors are getting better and better over time. So I have some videos here from the applications, but for example, now we don't have a human in this first experiment, but the robot knows how to find the best path to come to some place. And it is also used in evolutionary robotics, where the robot is able to change its form, how to adapt to different kinds of surfaces, for example. And neural networks are used especially in the problems of object recognition, classification, and prediction. For example, we were able to detect some objects, but yes, you can program it in another way. You can program it like this, that I show you this thing, I will tell you what does it mean, but then imagine we have two kinds of bottles, and I know that this is also a bottle and this is also a bottle, but the robot does not know that. But using neural networks, it has a special capability of generalization, so it will know also these different types of bottles. And now, in 2013, everywhere in media was deep learning, like a new thing. Especially because of Google and Facebook, of course. But from our point of view, it's nothing new. Deep learning are neural networks. And it means that you have different kinds of input, and the learning ability in neural networks means that you are trying to find the best way between inputs and outputs. So they're able to make changes in themselves. Yes, neural networks can do that. And the power of them is in connecting layers. But they're not brains at all. And It's nothing new because the first neural network, very simple, called perceptron, was invented in 1964. And these three, they are the basic ones. And usually, if you have some data, it's very useful to use neural networks because we use training and testing set. So for example, this was my program to how to build a training set used for a robot to know which emotional expressions the human is trying to express, like joy, sadness, anger, fear, disgust, etc. And this was used by Kinect sensor to build a training set, and then it was just put into the neural network. And we have some, well, not me, but the world has a very good experience in using these ones, for example, in speech recognition and also in self-driving cars. So very different kinds of application fields. But what is going on now in the present? For example, Google is trying to connect object recognition with natural language processing. So if you see this image, the output for the robot or for the system will not only be like it's a yellow car, but it will be a way of how human would describe this object. Like, for example, a yellow school bus parked in a parking lot. So they use neural networks together with object recognition and natural language processing in the same system. And it brings the problem that we have a lot of data, and robots like this, they don't have good computers. Well, they have good computers, but not good enough to process all this data. And what we are doing right now, we are connecting different kinds of platforms to one cloud computing service. They can share their knowledge, what they have learned from their experiences and from their environment. And yes, the robot has to be online all the time, but it has many good things. If you connect robots to cloud computing, and you can use cooperating machine learning somewhere else. We are using Azure from Microsoft, so we don't have servers in our lab. We don't need them. And we are building artificial intelligence as a service. On Monday, my colleagues are going to Japan, and they will connect Ishiguro's robot to our cloud. We have now enhancing robots, and using these techniques, it doesn't matter that their physical appearance is different, everything is different, but they can build the same cloud-based knowledge on the cloud. And so I think that the challenges now are using deep learning or neural network. For speech, we have to cope with noisy environment. It's still an issue in robotics. And also issues with big data. And then what I am doing is partner-like interaction, because we don't want humans to adapt to the robot.